Hi students, in this video we will talk about the different numeral systems. What does it mean? Numeral systems, we already know that we use the denary system. That means it's base 10 system. So let's say we have 10 $1 coins, we have the $10, and 10 $10 coins, we have a $100 notes. And sometimes we have another system. Let's say the time is a base 60 system. So you have 60 seconds into 1 minute and 60 minutes into 1 hour. So we have to know more about these kind of systems in this chapter. And we have many different types of numeral system, but in this chapter we will discuss 3 numeral systems. The first one is denary system. Denary system is base 10. We have binary system. Binary system is base 2. And the last one will be hexadecimal system. Hexadecimal system is base 16. So first of all, we talk about the denary system. The denary system, we use it very commonly. We use it in daily lives. So it is 0, 1, 2, 3, 4, 5 to 9. So we would express all the numbers with these 10 symbols. Actually, these are symbols. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We can also call it as numerals, Arabic numerals. And so that these kind of numbers are using the denary system. So 134 base of 10, it means 134. 5168 base of 10 is 5168, so on and so on. And because we usually use the denary systems, that's why the base 10 here, we usually omit it. We don't write it in our daily life. How about other kind of values? And in denary system, let's talk about it a little bit more. We have to know that there is a fixed place value. So we have a number 2108.5. So it means that the place value for the first number 2, this numeral number, it means, okay, first of all we talk about the 8. 8 is the unit digit. The place value is 1. That means 10 to the power 0. And then the number 0 here, the place value is 10 to the power 1. It means 10, 0 times 10. And the value 1 here is the 100 as the place value. So 1 here means 100. And the 2 there will be the place value will be 1000. That means 10 to the power 3. And the last one, 0.1, 5 times 0.1. So the place value is 0.1. And we can change it into 10 to the power negative 1. So you can see that the place value starts from 10 to the power 3, and then 10 to the power 2, 10 to the power 1, 10 to the power 0, and last one, 10 to the power negative 1 for this number. So you all know that the digit represent these values. Okay, and the last one, 5, represent 5 times 10 to the power negative 1. So we add these value up, we will get this value in denary system, 2108.5. Sometimes we have to change it into other system, so we have to know about it. We have an expanded form for this number, so sometimes you have to write this expanded form. You have to know how to write it. And this value 0 is the placeholder because it doesn't represent any value, but we have to write down 0, so this is called placeholder. Otherwise, if we don't have this 0, we will not able to distinguish these two numbers, 2108.5 and 218.5. So we try to write down the place value of this number of each digit. So give your answers in index notation. So for 7, the place value is 10 to the power 2 because it is 700. And the 0, the numeral 0 here, represent the place value of 10 to the power 1, so on and so on. So if you want to express this number in the expanded form, we just write down 7 times 10 to the power 2 plus 0 times 10 to the power 1. Remember, you have to write down the 0 term, and the next one is 2 times 10 to the power 10 to the power 0, and the last one 6 times 10 to the power -1. Sometimes we are given the number in the expanded form. We try to find it back. What would be the number here? Okay, for part A, this one, we already colored the value. And remember, look at the last term is 10 to the power 0. So 2 will be the unit digit. So you have 10542 as the value of this number. And part B, look at this expanded form. And the last value, 5 times 10 to the power -1. So it should be 0.5 for the last term. So you will have 9700.5. And we will talk about the binary system. Binary systems, we usually use it in computers and networking. So in binary system, we only use two symbols, or we call it numerals. Two numerals will be 0 and 1. So in binary system, you can only see the terms 0 and 1. These values, 1, 1 in binary base of 2, okay, is a binary number. 101 base of 2 is a binary number as well. So the base 2 denoted that the number is in binary system. This time, the 2 here cannot be omitted. So how to find the value? So we look at this value, 1011.1 base of 2. So we try to find the place values. Okay, so each one, it will be, the first one will be 2 to the power 3. So this digit 1 means 1 times 2 to the power 3. Next one, 0, means 0 times 2 to the power 2. The third one, 1 here, means 1 times 2 to the power 1. So on and so on. So what will be the value of this number? We will look at the expanded form, 1 times 2 cube plus 0 times 2 square plus 1 times 2 to the power 1 plus 1 times 2 to the power 0 plus 1 times 2 to the power -1. And we found this value, 101.1 in the base of 2. So we try to find each value and the expanded form. It will be like this. So remember, before the decimal point, okay, that value, but the place value will be the 2 to the power 0 in the base of 2. So you will have these answers. So if we have the expanded form of a number in the binary system, we can actually write it back, okay, into this 111 and base of 2. For this value, look at the last term is 2 to the power -1. So the last one will be 0.1, and then you have 1100.1 in binary system. So you have to write down base of 2. And this value, so you can write down 111010, 111010, and this is base of 2 in binary system. Also, we can talk about the hexadecimal system. Hexadecimal system is the base of 16. So you will have 16 numerals. And we start from 0 to 9, we altogether have 10 numerals. And the 11th numerals would be A, and then B, C, D, E, F. Okay, but you need to know that A actually represents the value of 10, B represents the value of 11, C is 12, so on and so on. So if we see some of the number like this, 2, 3, D, and then it is has a decimal system, F7A, okay, base of 16, these has a decimal number. So also remember, we cannot omit the 16 as the base. So look at this example, 137C.8. So we know that the place value are as follows. And then we know that 1 means 1 times 16 to the power 3. 3 here means 3 times 16 square. 7 means 7 times 16 to the power 1. C here, okay, it means 12. Okay, C is 12 times 16 to the power 0. And the last one, A, is 10, okay, times 16 to the power negative 1. So we can write it as the expanded form. So in this example, we try to write down each place value for the digits. D to B 16, it means D to B, the place value is 16 square, 16 to the power 1 and 16 to the power 0. For the next value, 4E upon F, so F will be 16 to the power negative 1, E is 16 to the power 0, 4, the place value is 16 to the power 1. And we write it as expanded form, we just write it like this. Okay, D will become 13, B is 11, E is 14, F is 15. So we can write it back into, if we have the expanded form, we write it back as decimal number. Okay, and remember 12 and 15. 12, what would it be? It would be C. 15 is F. So this number will be 90CF8, base of 16. And for part B, 11. 11 is B. And the last term is 7 times 16 to the power negative 1. So it will be BO2.7 with base of 16. And last one, so this one, 14 times 16 cubed. So 14, what would it be? It is E. So 10, what would it be? It is A. So you have EA50 with the base of 16 to represent this value. So we will see you next time.